In section 1.4, we're going to talk about the basics of exponents and logarithms. What you need to understand is that exponents and logarithms are inverses of each other. So for instance, if you have a relation that is expressed as y equals a to the x power, then x is the exponent of the base a, which yields the quantity y. And the way you're going to rewrite that is x equals the log base a of y. And I put in a little asterisk there that a has to be a positive number. That base, in order for you to write it in logarithmic form, is a positive number. So I kind of want to go to the next slide where I kind of wrote this out for you. So think of a simple example, like 2 to the third power equals 8. Okay, 2 to the third power equals 8. 2 is the number, 3 is the power, 8 is the answer. So when you're going to rearrange this and write it from what's called exponential form, right there on the left-hand side because of the exponent, to what's called on the right-hand side logarithmic form, notice that the order becomes nap. You take a nap on a log. Think about it in those sense, okay? So then it's going to be number, answer, power. And the way you read this is the log base 2 of 8 equals 3. So the base, which is your number, is little, it's small, and then the answer is normal size, and so is the power. So let's go back to the previous slide. When the base is 10, we normally do not write it. We can simply write log y. And if you were to look in your calculator, in the graphing calculator next to the number 7, you'll find log. All of those answers are done base 10, okay? Because log is base 10. So a logarithm with base 10 is called a common logarithm. When the base is e, and some of you are probably wondering, like, what is e? Well, if you haven't seen e before, which a lot of you probably have, e is just the number 2.718281828, blah, 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 and it continues. It's irrational, okay? So when you have base e, you're going to write log as ln, the natural log. So a logarithm with base e is called a natural logarithm. When it is base 10, we say log. When it is base e, we use ln. So the exercises that you have to do basically require you to just go back and forth between exponential form and logarithmic form. So in question number 1, for example, we have 1,000 equals 10 to the third power. This is written in exponential form because I see an exponent. So the number is 10, the power is 3, the answer is 1,000. I'm going to write this as the log base 10 of 1,000 equals 3 because it's number, answer equals power. And I can drop the log base 10. I can drop the 10 because base 10, we all know when we see log by itself without a base, it's automatically 10. Part B, 64 equals 4 to the third power. Again, 4 is the number, 3 is the power, 64 is the answer. When you write it in logarithmic form, it's number, answer, power. You take a nap on a log. So it's the log base 4 of 64 equals 3. In part C, 100 to the 3/2 power equals 1,000. So the log base 100 of 1,000 equals 3 over 2. And the rest of the problems are literally all done the same exact way. It doesn't even matter what they're giving you. They're all done the same way. It's the log of the number, which is the base, and then answer equals to the power. The only one that's different here is G. So for G, we have e to the 0 power equals 1. Because in this case, it's not base 10, I'm going to go ahead and put ln. So the natural log of 1 equals 0. And the other one that's a little different is m, because if you notice for m, the base in this case is negative. And from our notes, I put in a little asterisk for you here that the base has to be positive. So actually, when I get to m, I cannot write that in logarithmic form because the base is negative. We will be talking more about exponential functions when we go into functions, but But for now, at least be comfortable going back and forth between exponential form and logarithmic form.